Ever wondered how a database application is developed and maintained? Today we will dive into the world of the database application lifecycle. This fascinating journey takes us through various stages, each crucial in shaping the efficiency, usability, and longevity of a database application. It all starts with gathering and analyzing the requirements of the application stakeholders. This understanding paves the way for the design and modeling of the database, followed by the implementation and development phase. Once the application is developed, it goes through rigorous testing to ensure its competency. The application is then ready for deployment, but the journey doesn't end there. The application is constantly monitored and maintained for optimal performance, and when the time comes, it is retired or decommissioned with grace. Join us as we journey through the phases of this life cycle, from the initial requirement gathering to the eventual retirement. It all starts with understanding what the application needs to do. The first, and arguably most crucial phase in the database application life cycle, is requirements gathering and analysis. This is where we dive deep into the needs and objectives of the application stakeholders. We're not just talking about what the application should do, but why it needs to do it and how it should perform. Understanding data requirements is a fundamental part of this phase. We identify the types of data, the volume of data, relationships between data, and any constraints. It's not just about the data though. We also gather functional and non-functional requirements related to database operations, performance, security, and scalability. Think of it as laying the foundation for a house. The stronger and more detailed the foundation, the more stable and efficient the house. Once we have a solid understanding of what we need, we can move on to the next phase, which is designing the database. The design phase is where we start to give shape to our application. Think of it as the blueprint for our digital architecture. The heart of this phase is the creation of the database schema, which is essentially a map that outlines the structure of the data we'll be dealing with. This schema is informed by the requirements we gathered in the previous phase. At this stage, we define our tables, which are the core structures where our data will be stored. These tables are made up of columns, each housing a specific type of data. For instance, a user's table might have columns for username, email, password, and account creation date. But it's not just about storing data. We need to understand how different pieces of data relate to each other. So we also define relationships between tables. For example, a purchases table might have a relationship with the users table, linking each purchase to the user who made it. Next, we set up constraints, which are rules about what data can go into each column. A username column, for instance, might have a constraint that each username must be unique. Constraints help maintain the integrity and consistency of our data. But what about performance and scalability? We need to ensure our database can handle the volume of data we're expecting, and that it can deliver that data quickly. This is where we optimize our design. We might create indexes to speed up data retrieval, or partition large tables into smaller, more manageable chunks. This design phase isn't a one-and-done deal. We'll likely iterate on it, refining and tweaking as we uncover more about our application's needs. We might even use tools like entity relationship diagrams or unified modeling language to help visualize and communicate our design. With the design in place, we can start building. Our schema is the scaffold upon which we'll construct our application, a guide that ensures we're building something that not only works, but works well. This is the exciting part, where our application starts to come to life. Now it's time to bring our design to life. The first step in the implementation and development phase is crafting the application software. This involves creating user interfaces, developing business logic, and establishing data access layers. Consider the user interface as the face of your application, the part that users interact with. The business logic is the brain, making sense of the data, while the data access layer serves as the backbone, connecting the user interface and business logic to the database. Next, we create the database objects, including tables, views, indexes, and more based on the design we've already established. These objects are the building blocks of our database, each serving a distinct purpose. Tables store data, views present data in a readable format, and indexes help speed up data retrieval, pivoting to the writing of database queries, stored procedures, and triggers. Queries are like questions we ask the database, pulling out the information we need. Stored procedures are pre-written sets of instructions that perform specific tasks, while triggers are automated responses to certain events in the database. These elements allow us to implement business logic and data manipulation operations. Finally, we integrate the database with the application code. This is where the magic happens, as we use appropriate application programming interfaces, or APIs, and frameworks to combine the separate parts of our application. Integration ensures the database can communicate effectively with the rest of the application, creating a seamless user experience. This phase is a substantial undertaking, requiring a deep understanding of both the specific programming languages used and the broader principles of software development. It's important to approach this stage with meticulous attention to detail, as the quality of the implementation and development phase will significantly influence the performance and reliability of the final product. The implementation and development phase is the bridge between design and reality. It's where we take our carefully planned design and turn it into a functioning database application. But our work doesn't stop here. After building, it's time to put our work to the test. Testing is all about making sure our application works as expected. It's the phase where we put our database application under the microscope and rigorously evaluate its functionality and performance. We kick off with unit testing, where we validate each individual component and function. It's like checking all the nuts and bolts in a machine to ensure they're working perfectly. Next comes integration testing. Here, we're interested in how the database interacts with other system components. It's like ensuring all the parts of our machine work together in harmony. Then we have performance testing. This is where we measure response times, throughput, and scalability. Consider it as testing how fast our machine can run or how much load it can handle. Finally, we conduct security testing to identify potential vulnerabilities in database access and data handling. It's like checking if our machine is safe from external threats. Once our application passes all tests, it's ready to be deployed. Deployment is when our application goes live. It's a thrilling moment, but also a crucial one that requires meticulous preparation and careful execution. To start with, we prepare the database for deployment. This involves data migration, which is the process of transferring data from the development environment to the production environment. We also carry out schema deployment, a task that involves creating database objects in the production environment based on our design. Lastly, we set up configurations that control how our database application behaves in the production environment. Once we have everything set up, it's time for the actual deployment of the database application. This stage is about moving the application from a controlled development or staging environment to a live production environment. It's a crucial step because it's the point at which our application becomes available to end users. But deployment isn't just about flipping a switch. It's a process that needs monitoring to ensure it goes smoothly. We keep a close eye on the deployment process to make sure it completes successfully and without disruptions. If anything goes wrong, we need to be ready to step in and resolve the problem quickly. And once the application is live, our work doesn't stop there. In fact, it's just the beginning of the operation and monitoring phase. During operation, we monitor database performance, availability, and resource utilization. We need to ensure our application is running efficiently and that it's available when users need it. We also keep tabs on resource utilization because it affects the speed and responsiveness of our application. But operation isn't just about keeping the lights on. It's also about ensuring the security of our database. We handle database security by managing access control, making sure only authorized users can access the data. We also ensure compliance with regulatory requirements, which can be a complex task depending on the nature of the data and the jurisdictions in which we operate. After deployment, we enter a phase of maintenance and enhancement. But that's a topic for another scene. For now, let's celebrate the successful deployment of our database application. Even after going live, our work is not over. The journey continues with maintenance, enhancement, and eventually, retirement. Maintenance involves addressing any bugs or defects that surface during operation. This could mean bug fixes, patches, or even emergency repairs. It's about ensuring that the database application runs smoothly and reliably, day in, day out. Enhancement, on the other hand, is about evolution. We incorporate user feedback and adapt to changing requirements. This could involve updates, enhancements, or database schema changes. The goal is to continuously improve the application to ensure it stays effective, reliable, and user-friendly. And finally, retirement. When the database application is no longer needed or relevant, we plan and execute its decommissioning. We might archive or migrate data for historical purposes or compliance. Then we remove or disable the application, conducting a post-mortem analysis to learn from the experience. And there you have it, the complete database application lifecycle.